Hi, and welcome back to the class. We are going to continue on with spatial analysis and focus on static maps. So last time we used Tigris to bring in the shapefile of Texas, right here. And look how it builds out like that. Eventually it'll finish. There we go. So next we are going to download census data into R via API. So instead of downloading data from the horrible to navigate census fact finder or the pleasant to navigate censusreporter.org, we can pull code with the census API package from Hannah Recht of Bloomberg. So she created this, I think I read on Twitter, because she was tired of dealing with those websites that I mentioned. So there's a link to how it looks on the website, and it's got great documentation. But I'll walk you through how to use it. First, let's bring in the library. Install it first, Census API, if you don't have it yet. I do not have it yet, so I'm going to, I need to first type it out. I do not have it yet, so let's install .packages. Keep typoing. Okay, and now I can load the library. So first, you can check out the dozens of data sets you have access to now via the Census API. So APIs, I'm going to create list census APIs is a function. We've got 275 of them. You've got ACS 1 year, 5 year, and then it tells you the vintage, which is the year of it. A lot of really great stuff. Decennial stuff. So we won't go too deep into the usage of Census API. You can always refer to Hannah's documentation, like I mentioned. We're going to just focus on using the getCensus function from the package. It makes an API call and returns a data frame of results. So these are the arguments you'll need to use this function called getCensus, and that's name, vintage, vars, and region. So name is the name of the census data, like ACS 5. Vintage is the year of the data set. Vars is one or more variables to access. So just like, remember in populations, B02, 001, 00, you need to have a list of those variables to pass to it. And then you can determine region, the level of geographic specificity that you want to give it, like county or tracts or state. So you can figure out, and this might take some time to load because there's a lot, but you can do you can get a list of variables of, let's say, the ACS. I'm going to create an object called ACS vars, list census metadata name, let's say ACS 5. Type, I want to see the variables. Vintage, I want to see all of them that are available in 2016. This might take some time to download. Okay. So we pulled 23,000 rows of data. And so it has the details, it has the attributes, and the name. Excuse me. So you can do a search in here to find out what you want. We got population, we got race, we got education. Let's see. So play around with it to see what kind of variables you might be interested in getting. You can also refer to the census for some guidance. There's a link to it in there. What else? We are going to pull in median income. And that will be we're going to get this one. Right. So let me put that in a comment to remind myself, B2021004_001E. Okay, so the function is, first give it an object, which is Texas underscore income. And the function is get census. And name is ACS5. Vintage is going to be 2016. Comma, vars is, and let's see, we don't want just that single one. We want some more stuff. We want the name of the tract, of the county name, and then, actually, is it B19? Need to double check this. Oh, okay. Actually, I don't want the B21. I want B10903. So let me replace that from here. Great. Okay, B109013 underscore 001E. And I'm going to get the, what is the M version? I think that's the error margin. B109013 underscore 001E. Okay. And next, after vars, we're going to give it the region equals, I want all the counties, so I'm going to type in county, colon, asterisk, which stands for the wildcard, which means all counties, and the region in, and I just want to say state, colon, 48, because we know Texas is state FP 48. Let's run that. And I've got too many commas. Name, ACS 2015, I'm sorry, vintage 2016, comma, vars equals, this guy, I forgot to put the C for combine. And I think that'll work. I need to give it my census key. So, before we move on, scroll back up to the section where you can add a key to your environment. sys.setEnv census, uppercase census key equals, and this is where you would put in the census key after you signed up for it and the website that I've indicated. Just type in your email address, your name, and then they'll email it to you. And then you put that right there. I've already saved it to my system, so I can't see it, but I think it's called, I've saved it there, so I'll, cool, that worked. And then read to reset it, and read environ, and then in quotation marks tilde / dot renviron. It's okay, it's just a warning. It should have loaded. So I'm not going to run this second line because it would show you my census key, but I'm going to run this line of code again, the function to get the census, and fingers crossed. It doesn't know the variable name. What did I do wrong? Let me copy and paste it this time. I had one too many digits in there. Okay, Texas income. There it is. Okay, it looks like the same. Oh, I gotta change that to an M. Let's run that again. There we go. Great. So we have this Texas income, which is median income for every single county in Texas. And remember, we pulled all the shapefile of all the Texas counties in the previous video. So now we have to just join them together. And because they're both data frames, it's very easy to do. So I'll create a new one for the combined called Texas Forever. And left join tex was the name of the shapefile. And the new one is tex income. And do I need to change the name at all? So let's see, we got county. county FP. Because you can see the name wouldn't be good to join on, because in Texas, name is just singular, whereas under Texas income, the name is the name of the county plus county, comma, Texas. So it wouldn't join successfully on that. So let's do by equals C county FP and equals county. Texas forever, it's now 14 variables instead of 10 or 5. So let's plot that out. ggplot Texas forever plus geom_sf, right? AES. And I'm going to fill it with this variable, B190130001E. And I'll give it a border color for each county as white, plus, you know, I have my theme void in there, plus, gotta get rid of those panels, .grid.major equals element line color equals transparent, plus that, scale fill, distiller, and I'm going to give it a palette of oranges this time. And direction, I think I like to use 1, otherwise it'll be reverse. Give it a name of median income. Plus that. Labs, labels. Title equals 2016 median income in Texas counties. Comma, caption is source US Census /ACS 5 2016. Okay, let's run that. Okay, didn't like something. Somewhere in the theme panel grid, it said no. Panel.grid.major element underscore line color is transparent, scale fill distiller palette equals. It's always the little things. All right. Okay. So that, why is white out there? Oh, you know why? It's because I need to put a parenthesis here. So you can always play around with the parentheses and aesthetics to see why something's acting up. So, okay. Pretty cool, right? Now you've got median income, the darker the color of orange, the richer the area. The lighter it is, the poorer the area. So, next, let us bring these things together and download census data and shapefiles at the same time. So there's the most recent package dealing with census data is called Tidy Census, right here. And it brings together what we've done above, the data and the geography, and it's created by Kyle Walker. So you can pull, he also created the Tigris package. So you can pull it, you can use it to pull data only with the Census API, or you can use it to pull shapefiles like with Tigris. Sorry, let me repeat that. You can use it to pull just census data, like we did with the Census API, or you can use it to pull shapefiles only, like Tigris. But with Tidy Census, you can download both. No joins necessary. I won't go into the particulars of looking up geography types and census variables, so let's go right into mapping. We'll calculate the unemployment percents by census tract in New Jersey. It'll involve wrangling some data, but querying the data with getACS, the function, will be easy. And so we'll get in the shapefile by simply passing it to geometry equals 2. I'll show you what I mean. Let's install the package first. Tidy Census. And load the library, Tidy Census. pass it the census key. So the version for the use of census key here is census API underscore key, and then I have it loaded on my system as this variable already object, and I can say install equals true if I want to keep it forever and ever. Okay, so first of all, let's create an array with these variables, labor force and unemployed. I already know it already, so I'm just going to tell you what it is. Labor underscore force equals, and the variable is B23025 underscore 005E. And then the next one is unemployed equals B23025 underscore 002E 002E. So now I have jobs in here. Okay, now I just create a new object called Jersey, and I'll use the getACS function from tidy census. Give it, what we need to give it is geography equals, and I want census tract, right? Year, vintage over for tidy census is year, so just give it 2016 as well. Variable equals, and I'm going to pass it the array that I wanted, that I created right above it, comma, where. County is Hudson County in Jersey. State is NJ. And because I want the map as well as the ACS variables, then I could say geometry equals T for true. There it is. Jersey is right here. 6 variables, 332 census tracts in the county of Hudson. And you've got the estimate, and you've got the margin of error, and you've got the geometry all in one. So time for some math. Because we got Jersey, and you see in here, we got the variables that are stacked tidy style, right? We like that. So now we can do some math. Let's bring in first dplyr and tidyr to clean this up. Library tidyr. I think I have, well, just in case, I'll bring in dplyr again. So let's start with Jersey and create a mutate for variable equals case when. So I want to be specific. So if the variable is this, I'm going to rename it pretty much. So instead of this code number, I'm going to change it to unemployed. And so one variable the other way. Actually, I should switch this. This is unemployed and this is workforce. So I'm cleaning that up first. Then pipe that to the next thing, which is get rid of the .moe because we're going to spread it. Spread what? Variable. And the estimate. Because that's what we're going to have left, variable and estimate. And then I can mutate percent unemployment. So let me quickly run that to show you what that looks like. So I've got unemployed on one hand, on one variable, and workforce on the other. So now I can do some math. Percent unemployment equals unemployed equals round unemployed divided by workforce times 100, and give it to round it to the 2 digits. And now from here I'm going to pipe it directly to ggplot. So I don't need to name the data frame because I'm passing it into it with a pipe. So I just go start right off with AES. Fill is percent unemployed. Plus, give it a geom SF. Give it a color border of white. Plus all my themes. I'm just going to copy and paste it. Let's see, and I'll just readjust this. Color, transparent, scale fill. Instead of oranges this time, I'm going to use reds. And call this estimate. And label will be % unemployed in Jersey City. And the source and stuff is the same. I'll run that. Oh, forgot to put a plus here. It's so fun to watch it build in real time. Very cool. Okay, we're running out of time, but there's one more cool thing I want to show you. And that is, you know how you can make small multiples in ggplot2? You can do that with maps. So I'm just going to copy and paste some code over. We're going to use a new package called Viridis, which has a lot of really cool palettes. Great. And this time I'm going to copy and paste some code over so I can pull the race values of race from the census. So race vars is white. It's pretty much what I did before with jobs, but I'm creating a new array with race variables. So let's see, race vars look like this. Got that? So now I'm creating a new object called Harris for Harris County, and I'm going to use the decennial data set instead of ACS. And I want to pull geography tract. Variables are race vars. I'm looking at the state of Texas. County specifically is Harris County. Geometry is 2 because I want the map. And the summary variable is pretty much the unifying value for all these, right? So let me run these. So let's see what that looks like. Harris, 3,100 tracks in this particular county. It's got white, black, Asian, Hispanic. We've got, and the summary value, which is useful because this is the sum of each one of these. Okay, so let's visualize this. And first we need to do some math. Mutate % equals 100, and this is kind of a backwards version of doing the math. So 100 this time times in parenthesis value, summary value. So this way, when I do it this way, I don't need to do the whole spreading. Pipe ggplot AES fill equals % because I created a new one, comma color equals %. So fill and color. So I want the outside border and the inside value to reflect that. Plus, so I'm piping this to ggplot2. So now I need to transition to the pluses. So facet wrap tilde, and what I want to facet wrap by race, so variable. Plus, now that I can do geom_sf, plus I'm going to change the coordinates a bit, coord_sf. CRS is going to be 26915 plus scale fill viridis direction equals, I'm going to reverse this for this one, and you can always play around and reverse, re-reverse if you want, and scale color viridis direction equals -1. This is just this is pretty much the color palette that I want, and you'll see the range. Got to fix that typo, and then my things, which is theme void, theme panel, and then my labels. I need those. So just copying and pasting it, adding a plus this time. Color this time, I want to not use this because I've already set up the color scale above. And this time I'm going to label it racial geography of Harris County, Texas. And this time the source is US Census 2010. So let's run that. Let's try it again. Ooh, I'm still typing it wrong. Okay. It's going through thousands of grids right now, and it's thinking. Come on. I know you can do this. Yes! Look at that, populating. How cool is that? Now this is just your system doing this. This is not actually how it's going to populate when you present this. So from here you can save it as an SVG, as a PDF, as a PNG, just like a normal ggplot. Usually it doesn't take this long. It depends on your system, honestly. Boom. So yeah, from here you can save it. ggsave map.png, width equals 20, height equals 20, unit equals cm. Okay, while that's running, I want to talk to you about Alaska and Hawaii. Remember how we left it out that first time, unfortunately? Well, we can bring it back. And there's a cool way to bring it back. And before we do that, oh, the image is done. Let's see. How's it look? Double click. Ah, great. And so you see that the title kind of fixed itself a bit. So you can see where Asians tend to live, Hispanics live, where whites tend to live, and where blacks live. So there's a lot of distribution here. So Alaska and Hawaii. If you passed Shift Geo equals T to any of the functions like get ACS, then the states will be repositioned for you. All right. So let me show you this real quick. I'm going to copy paste it in. So I'm going to do county POV. I'm bringing in these particular values, and because I added Shift Geo2, when I ggplot it out, percent, this is, by the way, looking at percent of poverty. So now I'm going to map it out. Let that load. Ta-da! Alaska and Hawaii are there at the bottom, just repositioned. Alright, so great job. We've made a lot of really interesting static maps, and hopefully we can take this and apply this to other cool visualizations. Next, we're going to learn how to geolocate data using R. Alright, I'll see you then.